Thank you, Dr. Jeremiah Justice and Mr. Don Cairo for having me today. I have been looking forward to delivering this lecture to you for a long time, and maybe it got delayed because of several reasons. But nonetheless, I am very pleased to talk to your students, both at undergraduate and post-graduation level. Thank you for the wonderful introduction, Dr. Rawat. Yes, I'm currently teaching as a lecturer in forensic chemistry at ARU in Cambridge, UK. Well, the relevance of this presentation in terms of my experience is that I have worked as a junior analyst at the National Dope Testing Laboratory in New Delhi for a couple of years. And that experience, of course, I would love to share whatever little I have learned and still learning in the field of anti-doping analysis. So thank you for having me again. The contents of this presentation will be divided into several topics, and I have listed them here. We'll start with a quick recap of what doping is about in sports, about the prohibited substances, the list that is given by WADA, the methodology for the detection of some of the drugs, what is athlete biological passport, and then I will be focusing on one of the many categories of anti-doping. I'm sorry, pardon me. The anabolic agents or the steroids that are banned in sports. Of course, 1 hour is not enough to go through each one. That is why I've intentionally selected one of the most popular or the most abused drugs in doping. I will also be going through 3 papers that have published between 2002 and 2018. I've intentionally selected these papers because of their methodology, and we will be talking more about that. And also because they are using 3 different techniques. All 3 are GCMS, but then the detectors are different. And then lastly, I will finish by talking about the challenges in anti-doping analytical research. All right, so quickly going through the doping in sports. What is doping? Basically, anything that enhances sports performance in the field of sports, and any drug or any method that increases either strength, skill, endurance, and recovery are categorized as sports performance doping agents or methods. Dope testing in sports is done by the identification and quantification, as was introduced, and any methods that help in this are considered as substances or methods in sports. Now we have definitely biological samples that are tested both in and out of competition, and we're going to talk more about that. Now, WADA has put out a list of prohibited substances. Those are around 250 compounds, and these are subcategorized in S0 to S9, these substances, and methods, M1 to M3. We're not going to talk about methods today, but just the substances that are relevant to gas chromatography, mass spectrometry. Now, in various parts of the world, there are several accredited laboratories, and this accreditation comes from WADA itself. Okay, so it's not that any lab in the world can just set up a system where they are testing these athletes. So they need to be accredited by WADA. And we are lucky in India, we have a lab at New Delhi, the same lab where I was working. So if you see the map, this is a map that I have built, try to put dots exactly at where these are situated. You can see in Asia, there are not many labs. However, in India, Southeast Asia, India is lucky to have one. And I've both there and worked as a junior analyst, because later I was picked up by the laboratory, same laboratory where I was an intern. But there are many laboratories in Europe, a couple of laboratories in the US, one in Canada. So this is the updated data, September 2022. There are about 28 countries having 30 laboratories altogether. Now, talking about substances, these fall into two categories basically. One is a non-threshold category, and the other is a threshold. Non-threshold, as the name suggests, the identification, the drugs that are in this category are only the identification is enough to prove an adverse analytical finding. Okay, you don't need identification. Only if you find these drugs in the athlete sample, they are in trouble. Okay, as compared to the threshold, you need a certain prohibited level or a threshold level above which these compounds or drugs are banned. Okay, so when we are testing the athlete samples, we need to be careful about set threshold or not in order to report an adverse analytical finding. Now, some athletes may argue that they are taking certain drugs for an ongoing medical treatment. Okay, they may have gone through a surgery, they may be suffering from a disease, taking those drugs. For that, WADA provides the TUE or therapeutic usage or use exemption. Okay, this is a certificate given or a declaration given by the patient submitted to WADA under the stating clearly the circumstances under which he or she is taking that drug. So that does allow the participant to go ahead with sports career and does not fall under the doping, even though such drugs are found in his or her sample. So just to recap, anything that enhances sports performance is called cheating. Okay? As compared to somebody who's not taking these drugs, it is unfair to them. Okay. Health risk to the athletes. Some athletes may just want to continue playing even though they have an injury. Okay. Now that poses a health risk to the athlete themselves. Okay. They need to be well, they need to be physically and mentally fit in order to perform. Sometimes they overlook their health in order to kind of just go with the competition and go ahead with participation. Thirdly, anything that violates the spirit of sporting is called unsporting. So anything around this, if any substance or method is in the athlete's sample, they fall under prohibited substances, or they are said to have a doping agent in their system. So every year, WADA publishes the prohibited list, and WADA keeps on updating this list every year. The last list that was published, that is valid for 2022, was on 30 September 2021. Okay, so it's 1 year before they want. So this list is followed by everybody around the world. All the accredited laboratories swear by this list, and they to follow the testing of these particular drugs that are given in that list for that year. So the prohibited list for 2022 has certain subcategories. The one in the orange color that you see on the right side of this this chart are those drugs that are banned all the time, whether the participant is performing in competition or he's just practicing and preparing for competition. So these are called drugs that are prohibited at all times. They fall from S0 to S5, okay? Whereas the ones that are given in yellow color on the left side are the ones that are banned just in sports. So when there is a competition happening and the participants are tested for these drugs, then if that is found, they are banned. So they are exempted from participating, and they have to face charges for using a doping method. The one given green is called P1 beta blocker. These agents are only banned in certain sports, and I'll be talking about it later. So very quickly, I will not spend much time talking about what these are. You can find them in many textbooks. You read about them on the WADA website. But The S0 category are non-approved substances. Now, these are prohibited at all times, like I said. This is any pharmacological substance that is not found in the rest of the list, okay? So there may be designer drugs, there may be drugs that are under trial, these may be drugs that have just launched in the market and not much research has been done on them. But if these are found and WADA decides to put them in this category, then if the athlete is taking for whatever reason except for TUE, they are in trouble. So now coming to the gas chromatography mass spectrometry techniques. Firstly, one of the papers that I found published in 2015 used a simple GCMS quantitation method. Okay, so this method was specifically designed for 7 endogenous steroids given by Herrick, I think, et al. That's how his name, I think, is pronounced. So he found that for his method, what he did or what they did, 4 deuterated derivatives were used as internal standard, okay, to account for variable. Now we know internal standard in GCMS methods is used for the detection of variability in matrix, okay, and to increase the extraction recovery. The method that they followed, they used SPE, solid phase extraction method. They used C18 cartridges. Okay, they activated it, they conditioned and rinsed it. Then the urine sample, very little urine sample is required for solid phase extraction methods. They spiked it with the internal standard mixture. Okay, and they extracted it. The extract was then evaporated. And then later to the dried extract, they added phosphate buffer and beta glucuronidase. Okay, now this is an enzymatic hydrolysis, okay, method that they do for AAS, anabolic agents. The samples were then cooled and then they extracted it with diethyl ether by shaking. So this is a liquid extraction step that they used following SPE. The samples are then centrifuged and frozen. The organic phases collected, solvent evaporated, and the dry residues were reconstituted in diethyl ether. Okay, derivatization. We need to do derivatization for GC methods. Why? Because derivatization will convert them into compounds that are compatible with the GC instrument. So they used MSTFA. It is one of the most popular derivatizing agents in GCMS. Okay, and then GCMS was performed. The endogenous steroids were used to establish a calibration curve. And then we all know how GCMS calibration curves work. You find the concentration of unknown compound by checking its position on the calibration curve. Okay, so the GC conditions that they used a column, an Agilent system. With an autosampler, the mobile phase used was helium, flow rate 1 milliliter per minute. Injection volume is very little in a GC. If you've seen a GC vial, it's very small. So what we used to do at NDTL, we used to process at least 50 to 70 samples per day. Okay, that was routine testing every single day. We used to prepare those samples, put them in vials, and send them to GCMS instrument for analysis. Okay, in this particular instrument, they have used split mode. Okay, split mode will reduce the sample volume that goes in the instrument, and then the temperature was ramped. Temperature ramping is required for the proper resolution of the peaks on the GC chromatogram. The total runtime for each sample is 22 minutes. So the way it is done in these labs, they will inject the sample and leave the sample overnight. The instrument is going to run the samples the whole night, the overnight. And then when in the morning we come and then we get the data already. Okay, so that is programmed that way. Injections are usually done at night or in the evening. Okay, the MS was a quadrupole that they used, and electron ionization was used. Electron ionization is a hard ionization technique, like we know, but it is also a very popular one. Data acquisition was done using selected ion monitoring mode. Okay, now the method validation. Now WADA has given method validation guidelines. Okay, and the samples are analyzed using reagent blank. You need the blank, okay, the matrix blank. the blank urine sample, real samples, and then blank urine was run again, and then control sample. So this is just to check if there is no contamination of the instrument itself. Okay, this prevents any carryover of the analytes from one sample to another. Okay, this order needs to be run before the actual samples are run. And I think this is one of the most important steps before we proceed on to finding concentrations and reporting them. Okay. Now, calibration curves were constructed. The mean peak area for 4 measurements for each 3 calibration curves are run. So you have to understand, before the actual sample is run, a proper calibration or the method is validated to with utmost precision. The reason being, the athlete can always challenge the methodology used, or his defense lawyer can always come up with reasons saying, oh, this is not the correct concentration or whatever, because the instrument was not running properly or the method was not validated properly. So this is one of the most important steps in reporting an adverse analytical finding. Okay, the concentration of each steroid and its deuterated analog is measured and reported. Now, method validation was done using 6 to 8 concentration points for each calibration curve. And what they have used is testosterone, epitestosterone. They have used dehydroepiandrosterone, which is also called DIA, androsterone, eticolanone, and androstenediol. So these, I don't want you to get too worried about what these names are. Drug names are anyway not nice to hear and learn. But what is important here, they have used different internal standards, and they have used different drugs to draw these to plot these calibration curves, just to avoid any discrepancy in the future. Okay. And for high concentrations, of course, you don't want the column bleeding. So you will use appropriate dilutions wherever it is required. Coming to LOD and LOQ. What is LOD? Limit of detection. LOQ is limits of quantitation. Now, we already know that these have standard values, and we use the ratio of the X values and the Y values, and we divide it by the slope. Okay, and we multiply it by a multiplication factor to get the LOD and LOQ for that method. Now, this is all theoretical, which you already must have learned in while doing your instrumentation and method validation. So I'm not going to go too much into the detail. For coefficients of determination, which is R-square values, again, these are calculated for all the calibration curves before they start doing the analysis. Okay. For every 12 measurements, they were using 3 calibration curves, and each sample was repeated 4 times. Okay. And then obviously we know R-square values anywhere above 0.9900 is good, and 0.9980 is satisfactory. So they have to make sure that all these values are correct. Precision is defined as percentage RSD, okay, and it lied between 0.1 to 3%, which is again a very good range to define the method as valid. Accuracy was determined by the value of relative error less than 17.1%, and then proficiency test. Okay, so there's something called proficiency test that we do at dope testing laboratories, especially when one sample is sent to one lab, another sample, WADA will send the same sample to another lab. Okay. And then the values that they report in terms of concentration for that particular drug is compared between laboratories. That is called proficiency testing. So sometimes we used to get PT samples, and sometimes the WADA will tell us that these are PT samples. Sometimes they will not. This helps in maintaining the accreditation the lab has with WADA. If you fail this proficiency test, meaning if 1 or 2 or 3 or 4 or 5 laboratories report something else and you report something else, then, and you are an outlier, your accreditation is at risk. Okay, so labs have to be very careful. Each sample they consider as it may be a proficiency test, and also because the life of the athlete is in your hands. Okay, so all samples were prepared following all the procedure that has been described and analyzed 10 times. Okay, that is how particular, how precise these labs need to be. Okay, then recovery percentage was evaluated as the ratio of the peak area of the analyte to that of the pure standard. This is how we do. We also check the response of the analyte versus the response of the internal standard. and we come up with certain numbers. Now, this is just the values that I wanted to show. This is how they do it for the particular said drugs. They have a concentration range, and LOD and LOQ is found out for each drug. It's not that LOD is not for the for the instrument. It is for that particular drug on that instrument. Okay. These are again some values, don't have to be worried about. Okay. Now I don't know how much time we have. Should I move to the other methods, or
Yes, ma'am, you can go on. Yeah, you can take
okay,
it.
thank you sir. So GCMS-MS, okay, this is MS-MS is called tandem MS. This is another paper published in the year 2002, which was much before. However, I did not want to put this before in chronological order for a simple reason, because MS-MS is a more advanced, or it has two mass detectors that are coupled together, and the fragmentation happens twice. Okay, we all know the basics of tandem MS. Okay, so here, this obviously is a more sensitive instrument as compared to just a single MS. Okay, where we saw in the previous method, it took 22 minutes for the whole one sample to run. In this method, they proposed a method in which one sample could have detected or given the concentration in less than 7.4 minutes. So that reduces the concentration time by 1/3, okay, or the run time by 1/3. And hence it is a better technique. Now, what they have used the advantage of resolving power. I just said MSMS is a very sensitive technique, so it is going to have a higher resolving power and in a smaller amount of time. Okay, so in this method, they have not just stuck to anabolic steroids, they have tested S3, S5, S6, S7, and S8, narcotic stimulants, glucocorticoids, all these drugs. It's cannabis, S8 is cannabis. So they have tested all these drugs in single method. So what we have to understand, when a sample comes to the dope testing laboratory, we don't know what is inside it. Okay, so the way the dope testing laboratory works, we have a sample that is received in the laboratory, and it is in a good quantity, 50 to 60 ml, depends on 100 ml, depends on how much the sample has come. Then there's a certain department in the dope testing laboratory where they divide the same sample into different samples. They will put it in different test tubes, okay, and will send it for the screening of each category of drug, okay, to different subdivisions. So when I said I worked for the stimulants, narcotics, and plasma volume expanders team, what we were doing, we were receiving the same sample as and a double AS team would receive. Okay, so they perform or they extract the sample according to the method that will give a result for double AS, whereas we were doing liquid extraction, which would give results for stimulants, narcotics, and plasma volume expanders. So the methodology was different, but the sample was the same. The same sample was divided into, and hence, and also for the other categories. So each screening team is going to measure or put or inject those extracted samples in the instrument, and if they find something, a confirmation is going to be run for them for that particular drug. Okay, so when they devise this method, they have gone one step ahead. They have found a method that can detect all these compounds, drugs belonging to all these compounds, in one single method. Now, such kind of research, if you're interested in research in analytical chemistry, forensic chemistry, or sports doping, etc., you have to work on two things. Firstly, try to find an alternative matrix, okay, a matrix which nobody has worked on, and prove that it is better than urine and blood that is tested in routine analysis. Or you go for the same matrix and try to find out a technique or try to develop a method which is better than the previous existing routine methods or something that has been published in the research. Basically, all the research in the dope testing field lies in between these two. They will either be testing matrices or methods. Okay, now this is the last slide. What are the challenges in anti-doping analytical research? Like I said, doping is an ever growing field. So when dope testing started back in the 1970s, they only had a few compounds that were supposed to be banned or prohibited in sports. And those were mostly steroids, stimulants, and very popular ones. Now they have come up with a whole list, the prohibited list that we have just seen, from one S1 to P1 category. So there are lots and lots of drugs, and they are getting added every year. So no new doping agents are being added, which means more research needs to be done around the method validation for these ones. Okay. Biological specimens, they are trying to find out better and smaller amount of samples other than blood and urine. Why? Because transportation cost for urine samples, liquid urine samples, is much higher than, say, a hair sample. Okay, that can be transported in an envelope and just sent over. So the logistics are better when we are using the correct sample. Now, collection containers may be contaminated. So again, somebody who is helping an athlete, kind of get through this whole process and illegally helping the athlete, they will contaminate the container with something that will mask or that will hinder the detection of the actual abused drug by the athlete. Okay, so the collection process also needs to be very, very carefully selected. Okay, the analytical methods we've just discussed and seen 3 different techniques that can be used for the analysis of a few of the banned substances, and more research is going on every single day. If you just put dope testing analysis in Google Scholar, you'll find so many papers even being published today, because they're working on analytical methods. They might come a day where they will not take 7 minutes, 10 minutes to analyze one sample, or 250 or thousands of samples can be done in just a matter of few seconds. Okay, so they're working to that, with that aim in the future. Pre-treatment procedures need to be correct. You need to know when to use liquid extraction, when to use solid phase extraction. And nowadays, micro extraction techniques are also coming up, which will use very small quantity in microliters. Here, we're not talking about 10 ml or 5 ml or 2 ml of sample. We're talking about microliters of sample that will go in an extraction method. And so more research is being done in the field of micro extraction techniques. So anybody of you, especially the master students, if you're interested in dope testing research and research in this field, be aware micro extraction techniques are a very good way to go. Then you need reliable analytical results. You need proficiency testing. You need accredited labs. You need no errors on any part by anybody on the team. The reason these dope testing laboratories, even in India, they will not hire in hundreds and hundreds like forensic labs. There are many labs set in the country, versus a dope testing lab. They will only choose and pick people, and they are going to make sure that everybody is doing their job properly, because it's very different from forensic field. You need to be very precise. One step wrong and the whole process can go wrong. Okay, and we know that most of the errors are made during the sample processing step. Okay, the instrument mostly does its job right. It's the human errors or extraction errors that contribute to the overall irreliability of the results. Okay, and then costs. We know we are dealing with expensive instruments. LCMS is more expensive than GCMS. So we need to come up with methods that are going to decrease the cost in the future. So who knows, there might be an instrument that can be used in the future with lower cost, and the whole cost of the sample analysis will go down. Okay, so sample miniaturization is what I talked about, using micro extraction techniques and using dried micro samples. These days, there is much research going on the extraction of drugs, even from dried spots. Okay, even for crime scenes, even for dope testing, where they will prick the finger of the athlete, they will put a drop of blood on a filter paper, and that can be analyzed for 200 and 500 and 1,000 drugs, whatever that person is maybe taking. I mean, realistically speaking, they will not be taking 500 drugs, but whatever is present, whatever analytes are present, because the drugs get metabolized. So their metabolites are also tested along with the main compound. In urine, mostly metabolites are found. In blood, both the main compound and its metabolite will be found. Okay. And then lastly, we are moving to automated techniques because, of course, we need to reduce human errors. But I'm not sure if that is very good for all of us. Nonetheless, do not be worried. You need humans to run these machines also. Okay. So automation cannot be realistically all automated. Of course, it can be digitalized, but that digitalization also needs to be done by a human. Okay. But they say that machines make lesser errors than humans. That's debatable anyway, but that will also multiply the productivity. And that's all about today's presentation. I have taken references from some of these papers, and of course, I would highly encourage you to go visit www.wada ama.org/en. This is their official site, and you can find all information related to doping, anti-doping analysis, methods, research, grants. They also come up with projects and labs. If you would like to work as a dope testing analyst anytime in the future, please go take a look and read about it. And yes, and before you go for the interview, etc., it's a very good idea to go through what they have given, because in the interview, from my personal experience, I've faced interview twice at NDTL for different job positions, and both the time they are always interested in what you know about doping versus what you know about general science. They're not interested what forensic science, forensic chemistry you have learned about, but what you know about method validation. Focus on that part, and yeah, that is a good way to go.